Hello viewers, this is Mr. Banda, Mathematics Made Easy. So in today's lesson, we are looking at Cambridge Igcse Additional Maths 0606 and question paper number 12 of 2022, paper 1. So we have this question with us here saying a cave y is equal to f of x is such that dy, the second derivative, that's d2y over dx squared, dx squared, that is the second derivative of y with respect to x, is equal to 2 minus 3x to the power negative 1 over 3. And the cave passes through the point negative 2, 10.2. And the gradient of the tangent to the cave at the point negative 2, 10.2 is given to be negative 6. Then we are required to find the function, which is f of x. So this question is derived from the concept of application of differentiation, application of integration. And one important application of integration is that it can help us to obtain a function when the derivative function is given. In this case, we are given the second derivative function, which is 2 minus 3x exponent negative 1 over 3. Now, in this case, when this is given, since for us to obtain the second derivative, we have to differentiate the function twice. So you differentiate the function. For the first time, you get dy dx. Then you differentiate the dy dx, or the derivative function. Then you will get the second derivative function, which is given. Therefore, for us to go to or to reach to the function itself, we are supposed to integrate the second derivative twice. The first integration will help us to go to or to obtain the first derivative, which is called the gradient function of the curve. Having obtained the gradient function of the curve, we are going to now going to integrate it to get the function itself. So that is the what we are going to do. Now, there is a very important piece of information given to us in this question, saying the gradient of the tangent to the curve at the point is negative 6. Now, how does the tangent, how does it come in when we are talking about the function? Don't forget that the gradient of a tangent at a point of tangents is going to be equal to, or is equal to, the gradient of the curve itself. So this is just a statement trying to see if you as a student do understand that the gradient of the tangent is equal to the gradient of the curve at the point of tangents. That's why instead of just telling you that the gradient of the curve at the point is negative 6, at the point negative 2, 10.2 is negative 6, we are saying the gradient of the tangent to the curve at that point is negative 6. All in all, what we are going to do is the same. Now, let us work on this particular question. So what I was explaining is this. What we are given is the second derivative of y with respect to x, which is given to be 2 minus 3x to the power negative 1 over 3. Okay? So when we are going to integrate the second derivative of y with respect to x, when we integrate the second derivative of y with respect to x, we are going to get dy dx, which is the first derivative, okay, plus c. Now, when we integrate dy dx plus c, that is with respect to x, what we are going to get is the function f of x, okay, which is y. So what we are going to get is y, which is equal to f of x, then plus d. Okay, c and d are constants here. So this is the procedure we are going to take. All right, our aim is first to integrate that. So let us start by integrating the second derivative of y with respect to x. I'm supposed to put a 2 here. So let us integrate that. So we want to integrate 2 minus 3x to the power negative 1 over 3 with respect to x. In this case, we integrate this type of a function, okay, which is composed of a function inside using u substitution. So we're going to let u be equal to 2 minus 3x, okay? Meaning, what will be dx now if u is equal to 2 minus 3x? So, you know that du dx, when you differentiate u with respect to x, you are going to get negative 3, isn't it? Then you want to make the x subject of the formula. Okay, you can cross multiply here. You are going to have dx times negative 3, so it is negative 3 dx, giving you du. Then dx is equal to du over negative 3, which is the same as negative 1 over 3, then du. That is dx, okay? From there. So, we are going to substitute now. How? Where is 2 minus 3x, you put u, because we are saying u is equal to 2 minus 3x. So this will be u to the power negative 1 over 3. Where there is dx, you put negative 1 over 3 du. Then you integrate with respect to u now. Okay? So this is going to be equal to the integral of where there is u here, where there is 2 minus 3x, of u to the power negative 1 over 3. Then, where there is dx here, we are putting negative 1 over 3 du. So this will be negative 1 over 3, then du. Now, negative 1 over 3 is a constant, okay? So you are saying u to the power negative 1 over 3 times negative 1 over 3 times du. That is the same as the integral of negative 1 over 3 u to the power negative 1 over 3, then du. I've just written it starting with negative 1 over 3. Okay, this is the same as one of the properties of integration of a function is that the integral of c times f of x with respect to x is going to give you c outside, then the integral of f of x with respect to x. So meaning what we have here, our c is a constant, negative 1 over 3. So it can be brought outside the integral so that you just have negative 1 over 3, then the integral of u to the power negative 1 over 3, then du. That's what we're going to have. Okay, so let us integrate this. Let us integrate this and see what we're going to get. So this is going to be equal to negative 1 over 3. When you integrate this one, you add a 1 to the power. So you have u to the power negative 1 over 3 plus 1 over negative 1 over 3 plus 1. Alright, what do we get when we integrate that? Okay. So this is going to be equal to negative 1 over 3. Okay, maybe let me take it up here so that we can further, we can have enough space here to integrate. So, what is that going to give us? So this will be negative 1 over 3. Then you have u to the power. Now, what is negative 1 over 3 plus 1? Negative 1 over 3 plus 1 is the same as negative 1 over 3 plus a 1 is the same as 3 over 3, so that I have the same denominator as 3. So negative 1 plus 3, you'll get positive 2 over 3. So this will be positive 2 over 3 over negative 1 over 3 plus 1, you also get 2 over 3. Like that. So when you integrate, you are going to get that. Alright, this will be equal to negative 1 over 3. Okay. This exponent is not part of this number, it's just part of u. So in short, I can write this as negative 1 over 3. Now, u to the power 2 over 3 over 2 over 3 is the same as 3 over 2, the reciprocal of that. 3 over 2 times u to the power 2 over 3. Okay? So what I've written is this. This means that one. You know that dividing by a number is the same as multiplying by its reciprocal. So dividing by 2 over 3, dividing u to the power 2 over 3 by 2 over 3 is the same as multiplying u to the power 2 over 3 by 3 over 2. Okay, now I can expand this. This is going to give us negative 1 over 3 times 3 over 2 u to the power 2 over 3. Alright, you cancel this and that, you are going to get negative 1 over 2 u to the power 2 over 3. Okay, then everything plus a c. Now let us substitute. We know what u is. Okay, so we substitute now for u. So dy dx is going to be equal to negative 1 over 2. U is 2 minus 3x, then to the power 2 over 3, then plus c. Okay, that is the derivative, dy dx. That's what we get when we integrate the second derivative. But what is c? We need to know what c is going to be. Now, take note here that we know that this derivative, dy dx, which is called the gradient function of the function itself. So the gradient function, which is dy dx, is this one. But what are we told about the gradient to the tangent at that point? So at that point, the gradient is negative 6. And the gradient of a tangent, like I mentioned earlier on, is equal to the gradient of the curve. So meaning, where there is dy dx, I'll put negative 6. So to solve for c. So where there is dy dx, I'll put negative 6 being equal to negative 1 over 2. I know what x is at that particular point. So at negative 2, 10.2, the x coordinate is negative 2 here. So where there is x in this function, I'll put negative 2. And this is going to be equal to 2 minus 2, then minus 3, then negative 2, then everything to the power 2 over 3 plus c. Alright, so this will be negative 6 being equal to negative 1 over 2. And negative 3 plus negative 2 get positive 6. Positive 6 plus 2, you have 8 to the power 2 over 3 plus c. And what will be the answer to that one? So, we now have this here, where we have negative 6 being equal to negative 1 over 2, 8 to the power 2 over 3. Now, 8 to the power 2 over 3 will give you the cube root of 8 to the power 2. The cube root of 8 is 2, and to the power 2 will get 4. So, what we are going to have here is this is a 4. So, we have negative 6 being equal to negative 1 over 2. Okay, to the power times 4, because 8 to the power 2 over 3 is 4, then plus c. What is that going to give us? So I'm coming back here. To get that. So what is this going to give us? So this is now giving us negative 1 over 2 times 4 plus c is equal to negative 6. I've written it in that form. Negative 1 over 2 times 4 is negative 2 plus c giving us negative 6. Then we'll have c being equal to negative 6 plus 2. Then c will be negative 4. Alright, so we have solved for c. We know what c is. C is negative 4. So meaning our dy dx is going to be equal to negative 1 over 2 times 2 minus 3 over minus 3x to the power 2 over 3, then minus 4, because our c is 4. So this is the derivative function. The first derivative function is this one. So we know now what the first derivative function. Let us integrate dy dx to get the function itself. Okay, so let us now integrate this function to get the function f of x. All right. So what is f of x? Now we're saying f of x is equal to the integral of dy dx with respect to x. Okay, then plus c. So now we know what dy dx is this one. Okay, since we have used the c there, let us use d for the constant of integration for this one. So we are saying the integral of -1/2 2 minus 3x then to the power 2/3 minus 4 with respect to x, then plus a d. That would be our f of x. So let us integrate this one, then we'll solve for d, then that will be our function. So what is this integral? Now note that this integral is the same as the integral of -1/2 2 minus 3x to the power 2/3 minus the integral of 4 with respect to x. So you can split the integral. The integral of f of x plus g of x is equal to the integral of f of x plus the integral of g of x. That's what I've used, where I'm looking at this as a function and this one as a function on its own. So you integrate like that. So let us integrate that. So this is easy to integrate. I can integrate it right away. So this will be the integral of -1/2. -1/2 is a constant and it's being multiplied to this function. 2 minus 3x to the power 2/3. Then minus, when you integrate 4, you just get 4x. Okay, so I've already integrated that. So now I want to integrate, so I'm supposed to put with respect to x here to know that the integration is ending here. So now let us integrate this one and see what we're going to have. We just still use u substitution. So you let u to be equal to 2 minus 3x, meaning du will be equal to -3 dx, just like we've been doing. Then dx is going to be equal to -1/3 du. Okay, so now we can substitute now. So this is going to be equal to -1/2, the integral of, where there is this, I'll put u to the power 2/3. Then where there is the x, I'm putting -1/3, then du. Then I'll split this, bringing it outside. What I'm going to have is positive. This is -1/3 times -1/2, that will be positive 1/6. Okay, so I've taken the -1/3 as a constant outside, and it will multiply -1/2, it will give us 1/6. Then the integral of u to the power 2/3, then you have du here. Okay, when you integrate this one, what do you get? So that will be 1/6. When you integrate that, you are going to get u to the power 2/3 plus that's 3/3 plus 1, okay, divided by 2/3 plus 1. All right, what are we going to get there? We are going to get 1/6 times, when you add this, you are going to get, this is a 3/3, when you add you get 5/3, so this will be 3/5. Okay, that's what we are going to have. So I'm multiplying it by the reciprocal instead of just leaving it as the denominator there. Then even this one would be u to the power 3/, so that will be 5/3. So that will be the integral. Okay. Now you know that 3 into 6 is 2 and there 1, so this will be 2 times 5, which is 10. 1 times 1 is 1, so I have 1 over 10. So this is going to give us 1 over 10 u to the power 5 over 3. You know what u is. U is 2 minus 3x. Alright, that's what we have. So let us now put everything in place. We know what u is. So from here, bringing that this side, we're going to have our f of x to be equal to, we were integrating this one. So it will be equal to, the integral of that is this one. 1 over 10. Okay, u is 2 minus 3x. So you put 2 minus 3x. Everything to the power 5 over 3. Then minus 4x. Okay, plus d. Let us use the calculator d, plus d. So this is f of x. Now let us solve for d. Okay, let us now solve for d. Don't forget, f of x is y, since we are saying y is equal to f of x. So from here, this is where we are. This is f of x plus d. Let us now solve for what d is going to be. Because this particular curve is passing through the point negative 2, 10.2, where there is f of x, which is y, you can put 10.2, and where there is x, we can put negative 2, then we'll be able to solve for d. Okay, so in this case, f of x is 10.2 being equal to 1 over 10, and this will be 2 minus, so we have 2 minus 3, negative 2, because x is negative 2 at this point. At the point negative 2, 10.2, x is negative 2, then everything to the power 5 over 2 minus 4, where there's x, we put negative 2, then plus d. So we want to solve for d. So I'll start with this one so that we can have d on our left hand side. Now this will be 1 over 10, okay, then 2, negative 3 times negative 2 will get positive 6, then everything power 5 over 3, okay, this is 5 over 3, then minus negative 2 times negative 4 times negative 2 will get positive 8, so that will be positive 8 plus d is equal to 10.2. So we can simplify this work. It's so easy to do so. This is 8, 2 plus 6 is 8, so you have 1 over 10 times, this is 8 to the power 5 over 3 plus 8, okay, then plus d giving us 10.2. All right, this one you have right here is the same as this one is the same as cube root of 8 raised to power 5. Cube root of 8 is 2, 2 power 5, that will give us 32. So this will be 32 over 10 plus 8, okay, then plus d is equal to 10.2. All right, so what do we have here? Over 1. 8 over 2 is the same as 8 over 1 is the same as 8 over 10. So that I have 10 and a 10 there. So I can add a 0 and a 0 there. So this is the same as 8 over 10. Then I add 32 plus 8. We are going to get 122. I think. I went there. So we'll get 112. So this will be 112 over 10 plus d. Okay, can I do this now? So this is going to give us 112. 112 plus 10, because 32 plus 8 you get 112. I mean over 10, then plus d is equal to 10.2. Okay. Now, what is 112? What is 112 over 10? It's 11.2, isn't it? So 112 over 10 is the same as 11.2 plus D, giving us 10.2. Then D is going to be 10.2 minus 11.2. Then D is going to be negative 1. Check that 10.2 minus 11.2 will give you negative 1. So we know that now D is negative 1. We can now write the equation or write the equation of the function f of x. So therefore, f of x is equal to 1 over 10, okay, 2 minus 3x to the power 5 over 3 minus 4x. Then D, where there's plus D, we'll put negative 1. So this is the function f of x. Okay, check that when you differentiate this function twice, you are going to get 2 minus 3x to the power negative 1 over 2, negative 1 over 3. Thank you so much. I hope and believe that you enjoyed the lesson. May God bless you all, and please do not forget to subscribe to my YouTube channel so that you can learn more and more of the content coming from Cambridge International Igcse SE Additional Maths 0606. Thank you so much, and God bless you once more.